Sum and different identities. There's a lot of different sum and different identities. Here I'm just going to do an example of the identity sine A plus B. And the identity, you'll get these identities on the reference sheet on the Regents. The formula for sine A plus D, A plus B, the identity formula is sine A cosine B plus cosine A sine B. And so that's what we're going to use. And I have examples here where I'm giving you sine A cosine B. But notice that what we need for this identity is you need a sine A, we have that, a cosine B, we have that, but then we need cosine A, we don't have this, and we need sine B, we don't have this. So we need to find those first. So that's kind of what you have to do first. So first let me focus on the sine A here, and from that I'm going to find cosine A. So what this tells me is we're in quadrant from pi to 2 pi, pi over 2 to 2 pi. We're in quadrant 2. So I'm going to draw my triangle. This is the angle we're talking about. Sine is obviously positive because we know it's positive in quadrant 2. 4 over 5, that's opposite over hypotenuse. And so I need that missing side of my triangle. Pythagorean theorem, you know, a squared plus b squared equals c squared. Tells me that x squared plus 4 squared equals 5 squared. Or you might just recognize that this is a Pythagorean triplet, so that actually is a 3. And you could do out the Pythagorean theorem, but I remember that or recognize that as a Pythagorean triplet, a 3, 4, 5 right triangle. But I have to be careful. I'm in the second quadrant. Not everything's positive here. Your hypotenuse is always positive, but your legs could be positive or negative. Pythagorean theorem is going to tell me positive because I'm dealing with squares and square roots and things like that. But I recognize that that 3 is on the x-axis and it's going to the left. So that has to be a negative 3 because I'm going left 3. Anytime you're using the x-axis to the left of the origin, it's negative. And so from this now, I know that cosine of A adjacent over hypotenuse is negative 3 over 5. Next, for angle B here, this tells me that we're in quadrant 3, and cosine is adjacent, negative 5 over 13. It makes sense that the 5 is negative because it's on the x-axis to the left of the origin. And now I'm looking for my missing side here, which is a y-axis value, and I notice that it's below the origin, so that's also going to be a negative. Plus, I know that sine will be a negative function because it's in the third quadrant, and so on. So sine of angle B, opposite over hypotenuse, well, I need this value. Again, I can do Pythagorean theorem here of negative 5 squared plus y squared equals 13 squared. But this is also a Pythagorean triplet that I know that works out to be 12 or negative 12 because, like I said, we're a y value below the origin, so negative 12 over 13. And so now I have everything that I need. Sine A is 4/5, 4 over 5. Cosine B is negative 5 over 13. Cosine A is negative 3 over 5. We found that. And sine B we also found is negative 12 over 13. And so I can do this a long way, or I can let my calculator do a lot of this work for me. Let's see. First, I want to do 4/5 times negative 5/13. I like to do my equations piece by piece, and I'm going to turn that into a fraction. Negative 4/13. So negative 4 over 13. Actually, that makes sense. I could have just kind of simplified it a little bit there. But I'm going to use my calculator for the other side too. Parentheses, negative 3/5 times negative 12/13 is decimal math, enter, enter. let's see, 36 over 65. Okay. I need a common denominator to add these fractions together, or again, I just let my calculator do that for me. So the answer plus -4 divided by 13 decimal, enter, enter, 16 over 65 is my final answer.